Hello Year 12 chemists, welcome to TP's Chemistry Cuts. In this clip I take you step by step through the procedure to calculate the unknown concentration of an acid using data from a titration that was carried out in class.
Right, so what I'm going to do then is take a set of measurements from one of you that you've just got, and we're going to take the average and then we'll work through the calculation taking in all the steps and what we need to do for each step for the final result. And then after that I'll do a 2-to-1 calculation. Okay, so the first thing we need is to work out our average volume for the base that's in the burette, and that's fairly straightforward. But before we do that, of course, we have to know which ones we're going to use. And which ones are we going to use and which ones wouldn't we use? Anyone?
The last three.
Sorry?
The last three.
So you use the last three. So let's make it very clear we're going to use the last three. But we're not going to use the first one because it's not within range. Remember, to be concordant, the largest and the smallest result should be within a range of 0.2 for excellence. Okay, and everyone, including Joseph, is going to be trying to go for excellence. So it's those three. So let's put in our average volume, and very conveniently that's 22.65 ml. Okay, now if you don't get a nice round number, round it up. Apparently that's what we're going to do to be consistent across all classes. Round it to 2 decimal places, because that's the accuracy of that measurement. That's the one you're going to use as your starting point in the calculation. Okay. Once again, I'll say it. Every single measurement in here must be quoted to 2 decimal places, because that's how accurate a burette measures something. So even if it's 0, you must put 0.00 to show you understand it's correct to 2 decimal places. Is that clear? Good. Okay. Now, the other thing is to make sure that you've got the appropriate equations conveniently on your page. I'm putting it in red, so you put it in pencil. And you'll need the rearranged version, which is N equals C times V. So you'll use both versions of those in the calculation. For me, there's a potential of getting things mixed up. So what I always do, and I've already said this, is to make a little table with everything in it, the known and the unknown, the volume, the concentration, and so on, so that you don't get the wrong volumes with the wrong reactant. Okay, so put it here. And our known is sodium hydroxide here. That will be quoted on the paper, so be aware of that. And so we've got NaOH is our known, and HCl is the one we're trying to find the concentration for. We've used the volume for NaOH is 22.65. That's in mils. We're going to need that in litres, because concentration is always measured in moles per litre by standard. So divide it by 1,000. You don't have to do the calculation yet, but it's ready and waiting, as it were. And this one is the one that's in the pipette, so that's going to be 25.00 over 1,000. And so our known concentration is 0.0583 moles per litre, and this one is question mark. So we're ready to go. If you haven't got a concordance set, then you can perhaps copy that down just for this calculation. Now the first thing we need is the reaction equation. Okay, you'll be given this on the paper. So HCl plus NaOH and to remind you again, the only part of this that we're really interested in is the reactant part. This is a known reaction, okay, We're not doing anything to do with the products. We just need to know what the ratio, the mole ratio of the reactants is. So we can equivalence them, the known to the unknown, in terms of how many molecules or how many moles of those molecules or particles are reacting together. And this is telling us it's a one-to-one reaction. So if we know the number of moles of one of the reactants, that's the same as the number of moles of the other, because we're going to exact endpoint, the exact endpoint of the reaction, where we've got an equivalence of moles reacting. So 1 mole of that reacts with 1 mole of that. That's what it's telling us. Okay, so we'll put an E there for equation. The next step then is to identify our known, and we can calculate an amount in moles of the known because we know the volume and the concentration. And this is where the first step of the process, where this table is really quite useful. Because you've got the two things together, the volume and the concentration, and you can just put them together. So I'll write this out in full. You don't have to write every single explanation of what you're doing as you're going along, because it'll actually be on the paper to prompt you. Okay, so we're going to calculate the amount in mole of the known. So looking at our, that's okay, it's the known. So if we look at our table, our known is sodium hydroxide. So N of NaOH is equal to C times V, which is 0.0583 times the volume, which I've already converted into litres. Don't forget to do that. So somebody could quickly calculate that for me.
1.32 times 10 to the
So
minus
1.32 times 10 to the minus 3 mole. And remember, if it's not exactly that, that's the three significant figures, leave the number on your calculator. Don't round it, but you can round the result to write on your paper. Okay? So, and don't forget to include the unit. Right, the next thing is we're going to use this equation. It's not there for decoration, it's there to tell us what to do. This equation tells us that for every mole of 1 mole of sodium hydroxide, I need 1 mole of hydrochloric acid. So if I've got 1.32 times 10 to the minus 3 moles of sodium hydroxide, I need 1.32 moles of hydrochloric acid, because I've gone to exactly the end point, and 1 mole is reacting with 1 mole, and so on. Okay, so we're going to relate the two together, the known and the unknown, using mole ratios. Okay, so N of HCl is equal to N of NaOH. It's a 1-to-1 reaction, and that's 1.32 times 10 to the minus 3 moles. So we now know how many moles of the unknown concentration species we've got. We can now convert that to a concentration, which we're aiming for, because we know what volume we'll use. Okay? So we can calculate the unknown concentration. So C, just remind ourselves, remember you're always given these equations, so if you can't remember, just think, where's that equation on the paper? That. To make this clear, if I'll just finish is equal to 1.32 times 10 to the minus 3 divided by 25.00 over 1,000. Can somebody calculate that for me? 0.0528. Yeah? Mole per litre. Don't forget the units, and don't forget to tell me that you quoted that to 3 significant figures. Okay, and so that is your S.